off the recording here. And let's do this thing. Boom. I'm just gonna share my screen. You can look at these notes and stuff. Oh, sorry. Plug my laptop in so the battery doesn't die in the middle of this. And we will be good to go. Awesome. Okay. So lots of stuff in the agenda today, which is super exciting. So I will just jump right in. And let me pull up the chat just so that got that there too. Okay, awesome. So starting off with, can you show some examples of working with date time in JavaScript? Just read this snippet in the Advanced Programming module and realized that we haven't had to work with dates much, but I know that it can be tricky, especially when incorporating time zones, savings, math, etc. The snippet, I think, is most experienced for using a date wrapper instead of the standard date class, as it simplifies manipulation, etc., etc. Can you demonstrate usage of a date wrapper and how to find and how to add, subtract dates? Okay, let's look at a date wrapper. So the little context for this: yes, dates can be tricky, especially when incorporating time zones. I had a several-year period of my career where, without fail, every time we went into daylight saving time or out of it, the next Monday at work, there'd be some kind of crisis because some script broke. I fixed bugs in the same script, I think, 3 or 4 crossovers in a row. Because the first time it happened, it was like, oh, we didn't account for it going into daylight savings time. And I would fix that. And then 6 months later, we'd come out and I'd realize that I'd gotten the logic wrong if you were going the other way. So there's a lot of like tricky stuff to deal with time zones. Time zones are one thing, and that can be tricky when like dates in your database, for instance, are saved with a certain time zone. But your application users might be all over the world, and like you've got to do that kind of math. The daylight savings time is the evilest, because what it means is that there are some days of the year where 1:33 a.m. happens twice. So that can be like really tricky. If you have a job that like it's going to run at 1:30 every day, well, that's going to run twice one day. And then there are some days of the year where like 2:43 a.m. just never happens. We skip over it completely, and it's just, yeah, it's a nightmare. It's insane. But all that to say, dates are tricky, and the built-in date object in JavaScript is not super great. It doesn't have a lot of helpful methods. It's not really easy to work with. If you want to do something simple like parse a date in a certain format or display a date in a certain format, you end up having to write an awful lot of code. And so let's look at one date library called Moment. So Moment is a node. Moment is a node module, or a JavaScript module. I guess it's not just for Node. And it, there we go. Ah, I see. Just get a console going here. And it provides a wrapper around the date function. So you just require like this with Moment, and then you can use Moment to create an object that represents a date. It's not a date object in the sense of it's not one of these new date objects. it probably uses that date object under the hood to do some of its implementation, but it's sort of an alternative date object, and you create it just by passing a string or a number of other things to this moment function. And what you get back is an object that represents a date. So I'm creating a few here for, important dates coming up or in the past. And just kind of like the date, if you just call it with, I think dates work this way. If you just call moment with no arguments, you'll get a date object representing right now. And I'm saying date object, and it's really a date time object, right? It's not just representing the date, but the specific moment in time, which is true of the JavaScript date object, I'm pretty sure. So there's lots of fun stuff we can do with this. Here we go. Lots of fun stuff we can do with this. I'm just logging out these two so you can see what they look like. And let's just start with that. Let's go down here and node. What did I call this module? Dates. Halloween is not defined. No, that's right. Let's add one more just so the rest of this works. Halloween. So Halloween this year is 2017. Let's say that's the, well, let's do 2017 Halloween. Yeah, 10/31. That's also my wife's birthday. Makes it easy for me to remember. Okay, so you can see when we just print out the dates this way, by default, moments will get converted to a string this way, where it just shows you a string representation of the date, kind of wrapped in a moment call. And then what we're doing down here later on, someone was asking about adding and subtracting. So adding and subtracting to date is useful when you want to say things like, okay, I know what today is. I know that it takes 2 days to ship an Amazon Prime package. So when can I tell someone their package is going to be there, right? You want to quickly generate a date that's 2 days from right now. And so moment gives you just a nice function for that, where you can just call .add and then some integer and then some unit, right? And so this unit can be days or weeks. And it'll create a new date. It'll actually modify and return the original moment object. So then you can use it to print out. And let's just change this. So, there we go. So let's just run that part. And I'll, just so we can stay focused here, we'll just uncomment the code we're looking at. So you can see we're getting this, package will be delivered on Saturday, July 22nd. So that's 2 days from now. That's the date that's been calculated. 2 days down to the second, right? This is not a really friendly way to output the date. And this is where the other things that a date wrapping library will give you is nice ways to format dates quickly. So there's a couple ways I can do this. I can say calendar, and that will give me sort of a nice human readable version, right? We'll deliver it on Saturday at 2:10 p.m. So this Saturday at 2:10 p.m. is this nice, really human readable string that .calendar gave me. And calendar, you could look in the docs. Calendar is kind of, it's a very flexible method. So if this date were 3 years from now, then obviously it couldn't just give me a day of the week, right? And it would say something like, will be delivered on, what is today? Today is July 20th, 2020 or whatever. And I guess we could see what that would look like. So if this thing wasn't 2 days from now, but it was 2 years from now, then we'd get something right. So it just gives us a date. It will be delivered on, and then it just gives us the date that it's going to be delivered on. So Moment has a lot of nice built-in methods for doing things like that. Other things we could do are, So here's just an example of like, subtracting a week from a date. So we take the apocalypse and we kind of roll back. So when we know to stop buying green bananas, you can call a dot format method on it to just specify like, this is the format I want the date in. And there's sort of a, what's the word I'm looking for? Sort of like a mini language of like date format characters you can use to specify what the date formatted in. So this is going to give me something like March 18th, 1395 or whatever. Like it's going to be the spelled out month with the 2-digit day and the 4-digit year. We can see that if I run this. So I'll get I guess it's the abbreviated month, right? February 7th, 2076, which is 1 week before the apocalypse, which, mark that down, 2076. In case you were wondering, you heard it here first. How would you get rid of the time when using calendar? Someone asks in the chat. That's a good question. I'd have to check the documentation. It may be that if you want to start getting specific that you need to use one of these other format methods that lets you say exactly how you want the date formatted. That's going to be down here in display. So calendar time. Interesting. So calendar time, it looks like takes a second argument where you can specify the formats you want. So you could do something like this. So you can actually pass in these format strings for the different cases. So calendar will format the date differently depending on whether the date it's formatting is something that happens today or the next day or sometime next week or yesterday or the week before this, or and this sort of like same else. This is the fallback case that we saw when we put it like 2 years in the future. So let's look at that. What if we wanted to do, this is the next week case. It looks like you can also pass in a function. So it's really flexible, apparently. You can like specify date formats for all these different cases, or you can actually write your own function that will take in the, looks like it takes in like the current date, unless you figure out like, how do you want to format it based on how far away a certain day is from right now. So that's, I'm going to go through the whole moment library, but docs are online, and those are the kinds of reasons you might want to use a date library if you're starting to do things where you're trying to like take a date and figure out, what's the date that's 6 hours after this date, or what's a date that's, a lot of times you end up with weird things like, okay, I need to figure out what day it's going to be in 103 hours, right? And this will let you do that kind of thing too. We saw format, add and subtract, and then parsing, of course, similar to formatting, there's a lot of different ways you can parse a date. So if you have a date that is going to be in a certain format, you can use Moment to parse it. There's a bunch of like built-in formats that it supports that it'll understand. And then I believe you can pass in a format string when you're parsing the date to say like, this is how you should interpret this date, in case you have something like custom that you need to be able to parse. Any other questions about date wrapper libraries, anything of that nature? Did I cover what was desired that I would cover? Cool. Silence means yes. So moving on to the next thing. If we set a variable equal to another variable, is it generally linking to the original variable, or does it ever get set equal to the same value? This is a fantastic question. I love this question. This question is so awesome that I'm going to need to like draw pictures. So let's go to my default whiteboard app, Google Slides. Okay, so the answer is sort of yes to both. So when you, I need something. So when you're passing variables around to functions or like assigning them to variable names, let me go back and make sure I'm reading the question right here. When you set a variable equal to another variable, is it linking to the original or does it, yeah, okay. So actually we can probably do this in code just fine too. Let's just open a new file here. So let's create an object. For, we got a number, which is going to be 1, and we're going to have an array, which is going to be 1, 2, 3, and let's make an object that has one of those, and string. Okay. So the answer to your question is actually going to be different depending on the type of the type of data that you're working with. So if I have something like a number, for instance, so if I have this number and I want to say like, okay, I want to get, and I'm breaking my own rules here using var, but bear with me. They're all constants. I guess I'm writing, well, anyway. So let's say we want some, we're going to create a new variable and we're going to assign number to it. So at that point, what's happening is for an integer, you can think of variables as boxes. So let's create a box with the number 1 in it. It's like a border around it, big one. There we go. Okay, so we have this box, and a variable is kind of like a box. It's a place in memory where we're going to store some data. And so there's our variable. This is our variable num. So num sort of, in our code, the word num, this is a better way to show this, is insert a word art shape arrow. There's my arrow. Okay. So in our code, when we say num, it's kind of acting as a pointer that points to this box, which is just a place in memory where we can store stuff. So when we, so num starts out empty, which gets represented as undefined in JavaScript. And when we come here and we say num equals 1, the box gets created, and then the value 1 gets stuck in the box, and it's stored there in some binary format, so it's actually going to look something more like that, right? But it's going to be the binary representation of the number 1, right? And so, so then we create this new variable later on. Come on now. There we go. So we're going to create a new var in our code called a, which is another pointer. So when that happens, this sort of happens in 2 steps. So when you see something like this, var a equals num, it's similar to this happening, right? It's just kind of a shorthand for that, like declare, hey, I'm going to create this variable thing that's going to point to a place in memory, and I would like to store in that the value of num. So these 2 lines are equivalent to what happens when you write them all together like this. So this box gets created in memory somewhere to hold whatever a is going to point to. And then when we say a equals num, what JavaScript will do is it'll go look at num and say, okay, num, what does num point to? Num points to this number. So I'm going to put that number in this box. So at that point, these are just two completely different numbers. They're not pointing to the same thing. A is pointing to a completely different place in memory than num is pointing. And so we can prove that to ourselves by saying, if we say, okay, num is now going to be equal to 3. What's going to happen is this 1 is going to get changed to a 3. JavaScript's going to see this num and say, okay, num, that's a pointer to this place in memory. Where is that? Oh, it's this box. I'm going to put 3 there. And A remains unchanged, right? Which is what you expect if you saw this code. Or I guess it may or may not be what you expect, but it's what happens. So if we log both of those things out, node new. We log both of those things out. We can see after this assignment, num is 3, and A is still 1. Is everybody with me with that so far? Okay, that's the easy case, right? It gets a little more complicated, though, when you're dealing with something that's not a number, but is an object. The thing about these boxes is that they're a fixed size. They can only hold a certain size of thing. And so what happens when you want to create an array, like array, is a similar thing happens to begin with. This pointer thing gets created, this variable array. It's a little bigger because array is a bigger name. And then a box gets assigned in memory to hold whatever array is going to point to, right? But then what happens is we do this, when we create an array this way, right? We use the square brackets and create an array. An array is like a data structure that doesn't have a fixed size, right? I can keep adding stuff to this array. And so it gets stored differently in memory. And arrays can get kind of moved around in memory if they start getting too big. And so what happens is what gets put in this box is an address. So this array, 1, 2, 3, gets stored somewhere else in memory. This array gets stored that has 1, 2, and 3. You can actually think of this, well, let's not go overboard with details. Just make this a little bigger so it looks right. 24, 24, there we go. So this thing over here is the array, like the actual data in the array. And you can kind of see there's some extra room down here. This array might like grow and shrink as we add numbers to it. And what array is holding, what this box is holding, is an address. This is going to be some number that represents a place, another place in memory, right? And so what you'll have is, so you can think of it as basically another pointer. You get an arrow. So this address sort of just points to this other place in memory where the beginning of the array is, where the array is actually stored. And so when we go to do something to that array, like array push 4, what happens is JavaScript looks at this array and says, okay, that's a pointer to a variable. Let's go see what's stored in that variable. And it'll say, oh, okay, I see. It's an array is stored here. And so I have this pointer to another place in memory where the actual array lives, right? So the only thing that's stored in an array is sort of like the address. Like, oh, this is where the array is going to be out in memory. And so when we push something onto that array, JavaScript says, okay, well, let's follow that link and then go to the end of where this array exists in memory and then stick 4 onto it. Peachy. So then what happens when you do something like this and say new array, or let's just call it B. And I say B equals array. With arrays, which is different than how it works with integers, but with arrays or objects, B gets created, pointing to a place, an empty place in memory that's just big enough to hold a number or a memory address. And then the contents of the array variable get stuck in the B variable, and the contents of the array variable are this address in memory, right? So we've basically just created another link out to here from B. So if we print B, I'll do this, well, do it this way so we can see it. If we print B, we should see the same array that's stored in the array variable. Because Gauge is looking at B and saying, okay, what's B? B is holding an array, so I'm going to treat this thing like an address, and I'm going to go and look up the address of the actual array. And objects work the same way. So anything that's an object or an array is going to be stored as a reference. So this thing is referred to as a reference, this like pointer to the location where it lives in memory, this like address is a reference. So when you're passing an array or an object to a function, or you're assigning that to another variable, the thing you're passing around is just the reference to the object. So if you then go and modify the object or the array, everything that's holding a reference to it will see those updates. They're all looking at the same object, the same underlying array. The exception to that is numbers and strings. Numbers and strings just get stored as numbers and strings. And now that I'm saying that out loud, I want to make sure that I'm right about that with strings. Actually, I think strings is the same as arrays. Let's double check. So if I say var c equals string, and then I say string dot trying to think of a destructive method on string. So string is the same strings. Strings, this page would ever load. Place. Turns a new string. So there are some string methods that will just modify the original string. Yeah, so trim will remove white space from both ends of the string. So if string has some white space in it, let's do this. So we start with a bunch of spaces before, and then we say string trim. And then we log C. Let's see what happens. All right, so C still has the original value and str. Neither of them got trimmed. That's not exciting. The trim method removes white space from both ends of a string. White space is, oh no, it returns a new string. Well, that's just not helpful. I know there are ways to edit a string in place. Boom, 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 boom. Turns a new string. All right, well, search me. Sorry, I should know this, but it doesn't come up very often. Can I do this in JavaScript? All right, I'm gonna have to punt on strings. I'm sorry. I'm just gonna admit that I do not know whether strings are passed by reference or by value. And I will look that up and get back to you. I'm just not sure how JavaScript does it, and it does not come up very often, I guess. Not often enough for me to have it memorized. But in general, unless you're passing numbers, and I'll get back to you on strings, you gotta be careful that when you are assigning one thing to another, you are just passing references of things around. It's not creating a whole copy of your object or a copy of your array. And that is important to know. And this is also why, while we're talking about it, this is also why even if array is set to a const, right? So I could say const array, right? Which kind of says array can't be reassigned. It doesn't mean that the array itself can't be changed. What it means is, what const means is the thing that's in this box that array points to, that can't be changed. So, 13136, this is always going to be 13136. Array is always going to have this pointer pointing to this array. But that array, we can go in here and add stuff to it and remove stuff to it and change values. The constant thing is what's in this box, which you would change by doing like an array equals. So that's why even though you could like const array and assign an array to it, you can still end up changing the contents of the array. You can move things around or add things to it. Does that make sense? Is that helpful? Yeah, Helen, I looked at replace, but replace actually, according to this, replace returns a new string. So it doesn't actually modify the array. It doesn't modify the string you're calling it on. It creates a new array that has the replacements that you want. Okay. Okay, so the next one. If multiple errors occur, which one gets sent to the E in a catch? Is it possible to catch multiple errors? And the next question, I'm going to roll these up because the answer to the second one actually answers the first one too. What does this mean? Throwing an exception causes the call stack to be unwound until the next enclosing try-catch block or until the bottom of the stack. Let's talk about the call stack. We are going to need more pictures. So that quote is referring to something called the call stack. Let's look at some code. So let's create a little contrived example here. I'm going to have a function named A that calls a function named B. And then I'm going to have a function called B that calls C. And then one more function called C that does some work, does a thing. And then down here, I'm going to call A, kick things off, right? So, and let's imagine that, well, let's just start with that. And we can imagine that each of these things return values. So let's say const R for return, and then I'm going to return R plus 1. And let's say that return 1 and let's do that. Okay. So we're going to call A. A is going to call B and then add 1 to its result. And B calls C and adds 1 to its result. So this thing should all roll up to print 3, if I have the code right. Yay. Okay, so let's keep that code over here to the side. And let's talk about the call stack. The call stack describes kind of how JavaScript, how the node interpreter is sort of walking through your code and executing it. So what happens is this function A gets called. And we're rolling through A, right? And we get into it, and maybe we do some work before this happens, but eventually we get to this thing B. we need to call B, right? So we've created this variable R, right? We created one of those little arrows with an empty box, and then we're going to figure out, oh, what do we need to put in that box? And right when we were about to put something in that box, this function says, hey, call B, call this other function, right? Right in the middle of our function, we're going to stop and move all the way down here and run some other code before coming back up here and continuing. And so what your computer does at that point is it takes the function that shape, give me a shape, give me a square. It takes the function that you're in, A, right? And it kind of packages it up. So this is the function A. And it's not just the function A, but it's sort of like it's the pointer to where you are in function A. So think of it as like a bookmark, right? Where it's going to go, okay, we're going to save our progress in A, right? We've gotten to this one point. We've created this R variable. We're about to assign something to it. And now we need this other result. We need to go run the B function and see what it's going to do. So we save up our state, we save up our progress, and we push it onto something called the stack. And we'll see why it's called a stack here in a second. But let's give it a big. So this is the stack, right? Send it back, right? So there's a stack. And we're going to make our stack blue. Yay, pretty stacks are blue. All right, so we stick it at the bottom of the stack. Boom, function A, that's the first thing. So then our code kind of keeps rolling along and it gets into B and it says, okay, we're going to create a variable named R and we're going to start assigning something to it. Let's create a box to put that in. Oh, look, we have to call C. Shoot, let's save our progress in B. And then we stick that little saved progress where we are in function B on the stack. And you can see that like what's going to happen, this box that we're pushing on the stack has things in it like the variable R, right? That box that I was talking about lives in this little it's called a stack frame, right? So it's all of the like local variables and data and the state we were in the function gets rolled up, stuck onto the stack. And B is going to have one of those too. And it's going to have its own R. And if I could get my slides to stop capitalizing things, and that gets stuck on the stack right on top of A. And you can see this is why the R down here and the R up there can be different because they're stored in different places in memory. They're in different places in the stack. So finally we call C, right? And we get into C, and C, we run through C, and C actually completes, and we get a return value. We hit this return 1, and we're like, okay, we've got a 1 now, fantastic. So then what's going to happen is that JavaScript is going to pop the top thing off of the stack, right? It's going to, okay, what was the last thing that we were doing? Or the most recent thing before this? Where were we? We got to get back to where we were before we called C. And it does that by popping this off the stack. So boom, that comes off. And we say, okay, let's resume whatever we were doing in function B at the time using the number 1 for whatever we were asking for. So now we know what C resolves to. It resolves to 1. We stick 1 in that little box where R lives, right? 1 goes in here, 1. And then we do this addition. We're going to do R plus 1. We're going to find out that's 2. And then B is going to return, right? So now we've got a 2, and we got to say, okay, where were we when we called B? And so we resume. This thing kind of goes away. Away, you're done. That gets thrown away. We don't need it anymore. Then we pop A off the stack, and we say, okay, let's resume our place in A. Where were we? We were right here. And we were about to assign something to R, and now we know that that thing is a 2. I'm going to stick 2 in R. And then come back down, and we're going to add 1 to R, and we're going to get 3, and then we're going to return. And then we're done with A. And when we return here, there's actually one other thing on the stack that we didn't show, right? Which is just the sort of global function. It's where we start, right? Sometimes this would be called main. But it's just sort of this outer context, right? Where this console.log lives. So that's the last thing we're going to pop back off. This one doesn't have an R. We're going to pop that thing back off and say, okay, where were we in main when we called A? We were right here about to pass something to console.log. and that happens to be a 3, and we get 3 printed out. So the stack is this data structure that's used as the code is being executed to keep track of where you were, right? So main gets pushed on first, then A will get pushed on when we call B, and then we get into B and we call C, and C gets pushed, and B gets pushed on, right? And so when you say throwing an exception causes the call stack to be unwound until the next enclosing try catch block or until the bottom of the stack, what that means is if in function C, instead of returning, or before returning, we said throw new error, no dice. When an error gets thrown, it stops the execution of function C immediately, right? We're not going to get onto this return value or anything else that's going to happen later in C. You know, nothing happens beyond this point. This stops immediately. And at the same time, we pop B off of the stack, right? We are back in B because C just blew up. And instead of resuming B like we normally would, we look at the place we are in B and we say, okay, an error has just happened. Is the place where B called surrounded by a try catch block in this function? And if it's not, then sorry, the A happens, sorry, we're in B now, sorry. So C throws an error, we look in B, is there a try catch block surrounding the place where C was called? And if there's not, then the error gets thrown immediately from B, right? And we don't get past line 7, and B gets completed, and we go back, pop A off the call stack, and we look to see, is there a try catch block surrounding the call point in A where B was called? And since there's not, see, we've pushed this off the stack. Since there's not, we go back to we go all the way down to the bottom of the stack, and we look in main and we say, okay, in main, is there a try catch block surrounding the call to A? So this is unwinding all the way down to the bottom of the stack. And if we get to the bottom of the stack and we still don't find a try catch block, then the program just terminates and that error gets thrown out, which we can see if we run node this program. So this thing runs and boom, error, no dice. The program just dies. It's not pretty. I don't like doing it. So the alternative here, right, is that maybe in the function A, we had a suspicion that somewhere down in the bowels of functions that B calls, something terribly, terribly wrong could happen. So we might have anticipated this scenario and said, we're just going to wrap that sucker in a try catch error, and then log just a little frowny face, right? So at this point, once we get all the way down here to the top of the stack, right, and we get into C, now we're in C and this error gets thrown, we're going to pop B off the stack. We're going to see if we're in a try catch context. We're not. We're going to pop A off the stack. We're going to see, okay, are we in a try catch context here? And we are. So we get ejected from the try block. So this return statement still doesn't get executed. As soon as B throws an error and we get off the stack all the way up into the A function again, and we get back here and we say, okay, we're in a try catch block. We're going to skip immediately down to the catch block of this. We're going to take that error and assign it to whatever variable is named in the catch block. And then we're just going to resume A down here instead of resuming A up here. So once this catch happens, A is sort of like continuing like normal. It's just continuing at a different point. It's going to resume from this catch down here instead of from further up. And then if there are more statements down here, they're going to get executed in either case, right? We've just resumed down here, and then we'll carry on as normal. And so we can see that here, we'll get the frowny face, and then we'll get dose, which is how I spell done sometimes. All the cool kids are doing it. Undefined. We're getting undefined because A is not returning. That return statement never gets hit up here. So we would have to have a new one down here. We're just going to return 42 because if all else fails, 42 is probably a good enough number. So you'll see we get the 42 passed back. Our program continues like a normal. So, so that should answer the second question, hopefully. And the implications of that should answer, I think, the first question, which was, if multiple errors occur, which one gets sent to the E in catch? And the answer to that is, if multiple errors really can't occur, right? So as soon as you throw this error, we are done. C is not going anywhere else. So even if you tried to throw another error here, you're never going to get to line 21 to throw an error because line 19 stops execution as soon as this error is thrown. So you're only ever going to get one error in a catch block. Does that make sense? I'm not sure who asked which question. But is that clear? Does anybody have any questions about that call stack, try catch, how errors bubble up? You'll hear that as like errors bubbling up through functions because they sort of like, you know, bubble up through the code, like from C to B to A, and then eventually there'll be this net around it somewhere, hopefully, that catches it so you can do something with it. It is very unusual to write a program where you would anticipate an error going all the way to the top and crashing the application, right? You can imagine that happening in a node instance in like a web server. Like the server would just crash, and then you're not serving new requests, right? So you're always going to, no matter what happens when, you know, so-and-so is posting a Facebook request, even if there's some kind of error that you never expected, you're going to want to have a try catch at some high level to say, all right, we don't know why your Facebook post really screwed something up, but we're not going to like shut down Facebook because of it, right? We're just going to, eventually you're going to resume and display some kind of an error page to that user and move on. Okay, if there's not more questions about that, then we're going to move on to there's a question about the phase 3 assessment, how to use error handling middleware, what is package.lock for, and object new versus object create. I have a hard stop at 3 because we're interviewing another SCP candidate at 3. So I am not going to have time to get to all of these. But I'll get through what I can, and then maybe we can post the rest of them in phase 2, and some of the other SAPs can jump in. So phase 3 assessment, what to expect, what to build for extra practice after we've completed the benchmarks. So you have anticipated me in that my first response is going to be like, do the benchmarks. If you feel great about the benchmarks, you're going to do great on the phase 3 assessment. And that is kind of my answer. If you're asking what to build for extra practice after you've completed the benchmarks, I would say that if you want to feel extra prepared, you could think of the phase 3 as like an interview, right? You're interviewing at a company called phase 3. And the phase 3 company spends all of their time building the same things over and over and over again, right? They do this stuff. So they're looking for you coming into phase 3, like, oh, okay, are you in a place where you're going to be able to contribute to building these things, right? Obviously, it's a little different than a company because phase 3, Punit's expecting you to come in there and learn a lot of stuff while you're there, right? But these are the things you're going to be working on in order to learn in phase 3. So if you finished all the phase 2 benchmarks and you're really confident that you love your code, you've gotten it reviewed, you know how it works, you can explain it really well, and you want extra practice, I would say peek at the phase 3 curriculum and take a look at some of these, like, okay, simple bookstore, what's that like? And if you have some experience like trying to build one of these apps, that would be a good like stretch goal to do, right? If you're already doing the work that they're doing in phase 3, then you should feel pretty confident about your phase 2 skills. However, I will say that the phase 3, the interview is sort of trying to assess that you've learned all of the things you need to in phase 2. And not everything you need to learn in phase 2 is going to be covered in any one module in phase 3. So in addition to making sure you can do the benchmarks, do go back in phase 2 and check your skills off, right? Look through the skills list, kind of familiarize yourself with this. Hopefully you've been doing this as you go, right? And checking things off. Make sure there's no unchecked boxes here if you want to be really sure you got everything, and maybe just skim through it as a review that like, okay, yeah, I can make an HTTP post. I know what a git merge does. And if there's anything that you're like not sure about, you're like, well, I think I know how to do this, but I don't know if my understanding of build an HTTP server with Node is like sufficient. If you have any questions, reach out in the phase channel, ask an SEP. We might be able to clarify that some. But I think those 3 things, like if you can do the benchmarks, if you've got most or all of those skills checked off, then you should feel really comfortable going in the phase 3 interview. If you want to like go the extra mile, you've got a couple days left before your interview is going to start, then maybe start looking at the phase 3 material. I'm chewing on that some. Another really good person to ask that question is Puneet, who's the phase 3 SEP. He may have a different answer than I do. And he will certainly have an idea if you say, well, I just want to start one of the phase 3 projects and just look at it and see if I can kind of cut my teeth on it a little bit. He might be able to point you to a good phase 3 module to start with if you're trying to like work ahead a little bit. But I would definitely say don't start pulling in phase 3 modules until you've gone through that skills checklist. You've done all the benchmarks and you've gone through the skills checklist and checked stuff off. Because there are a handful of skills that are not specifically covered in the benchmarks that are like phase 2 skills that we want you to have going forward. So keep an eye on that skills list. Danielle has useful information. I asked Puneet a question about phase 3 challenge, and he said, testing will be part of the phase 3 challenge. Don't need to know auth. Although it will be much easier to progress in phase 3 if you know simple authentication. Yeah. Okay, that's good to know. And I will say that you are going to need to know auth. You're going to need to know auth like to get a job doing this. It's probably going to be pretty relevant in phase 4. You don't want to get through this program and like not have gotten exposure to it. So phase 2 is your chance to like practice building your own like HTTP app with authentication. So don't skip over that one because it could come back to bite you in interviews or like as you're starting a new job and you're like, I've never really played with authentication. There's also a lot of other skills that you're going to like reinforce by doing the authentication module because it's built on like sessions and redirects and cookies and all this other stuff that you will use to build lots of things, not just authentication. That's my commercial for authentication. Okay, I got like 2 minutes before I'm gonna have to jump. How to use error handling middleware. Can you talk about middleware in general? How the flow works, i.e. what goes on inside middleware? Does it return something or just alter the rec object, for example? Okay, so middleware, that's an excellent question. I'm not gonna be able to do this justice in the time that I have, but I will try and give you a high level idea of it. And I'm gonna do this with pictures because that's what we're doing today. So you can think of middleware as, you can think of your app as a series of circles. So the internet is a series of tubes and your app is a series of circles. So what happens is you get this request object, this request that comes in, right? This is some user sitting at their computer, types into something into their browser, and an HTTP request is initiated against your server. And pretty early on, Node takes that HTTP request and like packages it up into this JavaScript object called the rec. And then Express takes that rec and starts passing it to different functions. So if we look in an Express app, which hopefully I've got something useful around here somewhere. Okay, so here is an Express app. Just edit the file. There we go. So in Express app, you see I've defined. We've got app, and then I'm doing app.get posts, and then passing a function. App.get post ID, passing a function. Each of these functions that I'm passing in here is one of these circles, and you can see that each of them gets passed to the request object. These are special, right? Because I'm doing this app.get, which is sort of putting some logic around this circle that says, okay, if the request path is not /posts, then just skip this one, right? Go around it, go to the next one. And it goes to the next one. All right, if the request path is not posts / some number, then skip it, go to the next one. So it'll skip it and it'll go to this one here, right? Middleware just inserts circles in the order that you include it. So when I do this app use body parser URL encode, right? URL encode, this function returns another function. And that function is now registered in this list here. And so when the request comes in, the first thing that's going to happen is it's going to get passed to it's going to get passed to this first circle. It's going to get passed to this URL encoded middleware, which is going to take the body or the parameters, whatever, and it's going to alter them, and it's going to alter that rec object. And so when it gets passed to the next circle, it's got new attributes. Maybe it has a session attribute added to it. The variables are going to get changed, and so each of these are modifying the rec and the result. So there's actually two of these things that get passed around, right? The request and the response. So
Trevor, can I ask you a specific question?
Yeah,
See in the code that you have,
yeah.
how you are passing rec, res, and next, and then in the catch block you're passing next. Is that kind of, are you error handling there? Like, are you basically saying if an error comes up, move to the next middleware that can deal with that, which would just be the error handling middleware?
Yes, exactly.
Okay.
Yeah. So then,
yeah, sorry, that pretty much answers my question.
Okay. Yeah. So yeah, next is basically saying like, I got in this circle, but you know what? Screw it. I give up. Just go to the next one, right? So instead of saying like result.send or res.render, this next is right. It's sort of like part of this, like, yeah, it's part of the routing where I can say, okay, just go to the next thing that matches. And so it'll end up falling all the way down here to error handling, wherever it is I've defined that, which is probably somewhere else in this application. Yeah, that's the basic idea. Unfortunately, that's all the time I've got for today, so I'm going to have to jump. But if there are still questions about any of this stuff or things left in the phase 2 office hours, just cut and paste the stuff into the phase 2 channel with the @phase2help tag. And I'm sure like Tanner and Jared and the coach can jump in and give some answers to some of these as well. Thank you all for showing up with such great questions today. This was fun, and I'm like getting a little hoarse. I'll see y'all later.